Hello and welcome everybody. Welcome to the second video of Mason Hill discussing Race Oncology, Byzantrine, all the good stuff. My first video was fairly well received. I know Titan's got a little bit out of it, and so this one is the follow-up, and there's been, for whatever reason, a bit of interest in this, so I thought I may as well give it another crack, and hopefully it helps someone out. This one's a little bit different. I've decided that my first video was focusing a little bit more on the science. What does FTO overexpression do in cancers, and where does Byzantrine fit in, and what effect does it have? And this work this video is based off a peer merger and acquisition comparison that I'd done and created to try and determine what would be a baseline sort of value for Byzantrine as an FTO inhibitor. And so I shared that post, and there were some people interested in hearing me talk about it on videos. So hopefully I can elaborate on some points, and it helps some people understand, a little bit more about what that post was trying to get across. A little bit about me. I received some feedback from my last video, and I'll try and implement a bit of that going through. So I'm an independent investor. I'm an independent researcher. I am invested in RAC. I have a degree in nutrition. I've completed my master's in dietetics. I have a published paper in Alzheimer's disease research. So I have an interest in research, and the space that RAC are working within is very interesting and very compelling. And purely from a science perspective, it has really drawn me in. And that's been a major driver for me to get interested in this space and to want to share some of the stuff that I learn with all of you guys. So this is a peer comparison to try and determine value, and to do that I've included non-FDA approved and FDA approved drugs, and this is some of the criteria that I've looked at. So I've looked at clinical maturity, some of the cancer indications, what were the synergies known, first in class versus best in class, which I'll discuss in a little bit more detail later. I've looked at a pipeline comparison, so for the drug companies that were bought out, was there anything else in the pipeline that could have added some value? And then at the end, hopefully the evidence will suggest, where a sort of baseline value or a value lies for Byzantrine as an FTO inhibitor. Okay, so I've included, like I said, non-FDA approved drugs. So we've got Juno Therapeutics, Loxo Therapeutics, and 47. So at the time of transaction, these compounds were not approved for any indication. And that's comparable to Race Oncology's drug Byzantrine, because currently it does not have an FDA approval. And so current baseline value I think it's fair to determine a baseline value based on that. Byzantrine has been approved in the past in France, but it lapsed due to a series of mergers. I won't go into the detail, but what we'll do today is we'll focus on these non-FDA approved drugs, and then we'll also have a look at Immunomedics, which has an FDA approved drug. So briefly, Juno Therapeutics, their lead compound was a CAR T therapy. It was bought out in 2018, and it was bought out for about $9 billion US. Loxo Therapeutics had an RET inhibitor that was bought out in 2019, and they were bought out for about $8 billion US. And 47's drug, they had a anti-CD47 therapy. Now, there will be a slight exam at the end of this, so best you guys start taking some notes. They were bought out for USD 4.9 billion. And so these three lead drug candidates will form the baseline, or they'll be they'll be something important to compare to. And as a sort of a top end or a higher value, or how does Byzantrine or Race Oncology compare to a large buyout, I've included Trudelbe. And for those that don't know, it was approved for triple negative breast cancer last year based on a phase 3 trial, and it was bought out last year in 2020 for $21 billion US. So these are the 4 companies that I'll be comparing to, and it's important to know that I will be looking at the data from an FTO perspective when I'm thinking about Byzantrine. So first of all, clinical maturity, you can see from these, actually, bit of feedback from the last time. Seems the Perth boys are pretty impatient actually. So they told me to hurry up, that 40 minutes was too long. So I'll try and get through this as quick as I can. It's a pretty complex topic. So yeah, I think the Perth boys may have to just suck it up, but we'll see. So clinical maturity, I've looked at the total number of patients that were treated and the total number of clinical trials. And it's pretty clear from these graphs that you can see that in comparison to the non-FDA approved drugs, Bisantrene, Race Oncology has been trialed in many more patients and many more clinical trials. Okay, when we compare to immunomedics, this data was taken from 2019, so there may indeed be some more patients that have been treated. There may actually be a couple more clinical trials that have been put underway. But this was the best information that I could get. It's important to note that all the information that I put across today, I'm trying to deliver what may have been known or what was known just prior to a transaction. Now, in comparison to immunomedics, there's an important consideration. So for those that don't know, and I encourage you to jump on Hot Copper and get involved if you want to learn a little bit more, but the City of Hope last year, 2020, discovered that Byzantrine was the most potent inhibitor of a protein called FTO. Now, historically, it was an anthracene or an anthracene derivative. If you don't know what that means, you best do your Googling because it's going to be in the exam. And basically, the way in which an anthracene was dosed in certain tumors, it was dosed, once every 3 weeks or once every 4 weeks. So what we'll see is a lot of these clinical trials, Byzantrine was being dosed as this anthracene, but to be dosed as an FTO inhibitor, you need to be dosing Byzantrine daily on a consecutive basis. And so when we start looking at or comparing to Trudelbe in terms of clinical maturity, this is Trudelbe here. So that's an antibody drug conjugate, and it's a very specific patient population. So they're only going to be picking patients that express a certain protein, and those patients come into the trial. And so what you'll see here is that they're focusing on breast cancers, but they're also using urothelial, endometrial, ovarian, but they're able to specifically target a population and use the drug within that population. When we compare to Byzantrine, it's got this historic data and this historic perspective of it's an anthracene, so we're going to use it as an anthracene. And so when we look back at the data from this fresh perspective, it's important to try and tease out some of the information that can probably give us a better indication of Byzantrine functioning as an FTO inhibitor. And the phase 2 single agent relapse and refractory AML trials is the best example for that. So this is a summary of the 5 phase 2 AML trials. So there was 5 of them. And what's important about this is when you dose for AML, you dose 250 milligrams per meter squared on 5 consecutive days, or 7 consecutive days. And then you will have a consolidation of 3 days at the same dose. So you have 7 days in a row, and then you have an additional 3 days after that. Now this is advantageous because for an FTO inhibitor, you need to be dosing on each day. So while these phase 2 trials have not targeted specifically, are we going to look for patients that overexpress FTO, the dose, so 250 milligrams per meter squared, and the dosing regimen, a daily regimen over 7 days, and then a consolidation of 3 days, would support that the FTO properties or the FTO inhibitory properties of Byzantrine. And so when we look at this data, although we don't have clinical maturity of Byzantrine being used as a specific FTO inhibitor in an FTO overexpressing patient population, we can see that even when it is used on a consecutive basis, this average CR rate, so this complete response rate, is around 52%. Now, if we compare that to other FDA-approved drugs like Bisantrene, which has a 29%, idarubicin, which has a 20%, and adriamycin, doxorubicin, which has a 35%, we can see that when Byzantrine is being used on a consecutive basis over 7 days and in that 3-day follow-up, it's actually demonstrating extremely competitive and better complete response rates than other FDA-approved compounds. So although we don't have clinical maturity of Byzantrine being used as a targeted specific FTO inhibitor, we do have some trials that show that, you know, when you do use Byzantrine, you know, on a consecutive basis, day after day, it can produce some pretty good results. Now, I went back through the historic trials to find a dose escalation study that had used Byzantrine on a day-on-day basis, and I ended up finding this one. So briefly, the City of Hope, they determined that a dose of around 7.5 milligrams per meter squared per day is safe to use, or is the dose that's required to inhibit FTO. And so that's why I was looking for low dose or dose escalation study that had used a low dose on multiple consecutive days. And this trial, basically what they'd done is they'd used these doses here over 5 days, and then they repeated that same process every 3 weeks. And so what we see here is a dose of 7.5 milligrams per meter squared per day would come in about here, okay, thinking about it from that FTO inhibitory perspective. And so what they've done is they've dosed at 2.5, 5, and all the way up to 90 milligrams per meter squared per 5 days, every 3 weeks. Okay, so what happens is when we look across here at these toxic patients and evaluable patients, we can see that there's virtually no toxicity. There's no toxicity evident at this very low dose. Okay, but when we start to increase the dose beyond 50, so when we go up to 60, we can start to see that toxic patients starts to increase relative to evaluable patients, and we can see that increase as the dose increases. And so looking at this data as a single data set, you know, you can say, okay, well, it's, you know, this is indicating that potentially a low dose of Byzantrine is going to be relatively safe in humans, but we may need to see more data. But if you compare this regimen, so this daily low dose regimen, to the phase 2 AML trials, where they used a dose of 250 milligrams per meter squared per 7 days, which demonstrated good clinical efficacy, and it also showed good safety and tolerability, a pharmaceutical company looking at this data, although it hasn't been used as an FTO inhibitor, they can see that, okay, well, this is suggesting that a low dose of Byzantrine is going to be beneficial, and so it would give a pharmaceutical company more confidence looking at this data and thinking about Byzantrine from a low dose perspective. And based on this information, I think that Byzantrine is far more clinically advanced than the non-FDA approved drugs of Juno, Loxo, and 47, and it is comparable in terms of clinical maturity with immunomedics. Now, in terms of cancer indications, so more patients equals more value, and what you'll see here is the number of patients or the number of cancers that have been linked to FTO overexpression is currently at 19, and in comparison to other non-FDA approved drug potential patients, it's much lower. As I mentioned, Juno Therapeutics is a CAR T therapy, so for those that are not aware, it's targeted to blood cancers only. Loxo Therapeutics is indicated in, so an RAC inhibitor is indicated for 2 different cancer types. It's about 2% of lung cancers and 30% of thyroid cancers. 47 was indicated in about 7 different cancer types. And so in comparison, you can see that Byzantrine as an FTO inhibitor has the potential to target so many more different cancer types, which means so many more different patients, which of course increases the value. And you can see that even in comparison to immunomedics, you know, Byzantrine has greater potential for patients. Now another big one, so I've been beating my synergy drum over in hot copper, and I think that we haven't yet seen all of the potential synergies that might work with Byzantrine. The City of Hope 2.0 paper might give some greater insight into that. Well, I've got my fingers crossed. But what you can see here, it's pretty clear that there are many more potential synergies with an FTO inhibitor than any other of the drugs. Now, 47. This number here is these 7 potential synergies here was taken from the clinical trials website, which is actually after the transaction date. So I don't know if those synergies are known or if there's preclinical evidence supporting that. It was very challenging for me to find. And you can see that these preclinical synergies here have been determined from preclinical studies. And you can see that Byzantrine has almost double the potential synergies at this current moment, but you know, more may come out as time goes on. Looking a little bit closer into Byzantrine and into the potential synergies and why I think that's important. So Byzantrine has been shown to synergize with hypermethylating agents, BCL2 inhibitors, and nucleoside analogues in preclinical models. Also, in a phase 2 heavily pretreated pediatric population, in a phase 2 AML study looking at heavily pretreated pediatrics, Byzantrine used in combination with cytarabine or RAC achieved a 46% complete response rate. Now, these drugs synergize quite well and it was very well tolerated. So Byzantrine actually also has in-human data demonstrating that it is safe, it's efficacious, you know, and it's well tolerated, which is a massive tick. And for me, this indicates that Byzantrine has far more potential synergies, which is very important, particularly when you start to consider the amount of money that these different drugs, the market value of these different drugs. So 73.5 billion in 2019, and they're expected to get up to 162.6 billion by 2026, with, you know, anti-PD-1 therapies being worth the most. And so based on this information, I think the evidence suggests that Byzantrine and RAC are far more have far more synergy potential. Now, first in class and best in class. I think this is extremely important, particularly for Byzantrine. This data was taken from a Nature paper that was investigating, you know, is it better to be first to market or do you want to be the best drug? And the answer was kind of both. So it's a little bit better to be first than to be the best, and that's indicated by this table up here. So if you're first and you're best, then you will capture 100% of the total market, you know. But if you're second to market and you're the best, then you're going to capture 12% less. So it's best to be first, and you capture the most amount of revenue and the most amount of revenue potential when you are first to market and when you are the best. And this figure down here is showing that if you are first to market and you are the best drug in that market and you stay that way for at least 2 years, then you will capture significantly more market than a drug that is better than you and comes in, you know, 2 years later. Which means that a clinically advanced drug is going to be advantageous because they have the opportunity to take control of the market for a longer period of time. Some additional factors that they looked at that I thought was quite interesting was efficacy in a patient group with unmet clinical need. Now, if we think about the recent phase 2 AML trial with Byzantrine, we saw a 100% response rate in extramedullary AML. Now, that is a patient group with unmet clinical need. And so we have clinical evidence, in human phase 2 clinical evidence demonstrating efficacy of an FTO inhibitor in a patient group with unmet clinical need. breadth of indications brought in the market. I've been both hands up screaming about this stuff for a little while now. It's pretty clear that an FTO inhibitor has, potential outside of just cancer, which of course brings in more value. So this is a bit of a look at our competitors, and just briefly, so the Juno Therapeutics buyout was for a best-in-class drug. So their lead drug, JCAR017, that was for a best-in-class CAR T therapy. So they weren't going to be first, but they showed better clinical efficacy than the drugs that were in there at the time. And so that was the main driver for that large $9 billion buyout, is the clinical efficacy that they showed. The other drugs, so Loxo Therapeutics, 47, and Immunomedics, they were buyouts for first-in-class or potential first-in-class drugs. And so you can see that for a drug that is first-in-class or best-in-class and shows fairly good efficacy, it can really drive that multi-billion-dollar buyout. And so looking at the competitors in the FTO inhibitory space, we have Byzantrine, which is first, and it's at least three times more potent than the next most potent FTO inhibitor. We have DAC51, which is a preclinical compound. We have SSD, preclinical compound, and we have Brequinar. So for the sake of this chart, we're not going to talk about Brequinar too much. It's found to be quite impractical. It failed as an organ replacement drug. It failed as an anti-cancer agent, and although it was found to be the second most potent FTO inhibitor in the City of Hope paper, it just has some data that suggests it may not be a good anti-cancer therapy. So if we look at these three, so what we'll see, what we can start to see, and what we can start to appreciate when we look at this drug discovery and development timeline, is Byzantrine actually, because it is now entering into those phase 2 trials looking at breast, AML, extramedullary AML, it is actually sitting at this phase 2 stage. And when you look at these other competitors that are 3 times less potent, they're still at this preclinical stage. And so what you have then is you have Byzantrine has the potential to be that first-in-class drug, and currently it is also best-in-class. So when we think back to that previous figure, Byzantrine then has the potential to be that first-in-class as well as the best-in-class. And for a pharmaceutical company, the history suggests and the evidence suggests that they're prepared to pay top dollar for a drug that is first in class or best in class, and I think that would be the same for one that is. I think that would only be larger for a drug that has the potential to be first and best. And if we want to delve into it a little bit more, in a little bit more detail, having that clinical maturity, already having that consistent dosing regimen, already having that safety and tolerability at high doses, clinically it's so much more advanced. And also going into a little bit more detail, if we think about needing 3 times as much DAC51 to inhibit FTO the same way Byzantrine does, if we think back to that dose escalation table that I discussed before, as the dose increased, you saw that toxicity increase. So when you start using 3 times more of a drug, there's the opportunity that you're going to see those side effects. There's the opportunity you're going to see something that maybe isn't so good. And so this is where I think Byzantrine really shines through and is very, very comparable to the other buyouts. So pipeline potential, all of the drugs, all of the main drugs that were bought out had something in the pipeline. The majority of the compounds were at preclinical stage. The one standout was for Loxo Therapeutics. So they had an FDA-approved drug called Bisantrene. Now that was producing about 840 million per year in sales, and so that's really the only compound that was adding significant value and that may have contributed to the eventual sale. Now for those of you that have read that post, you know that Loxo Therapeutics, their main drug, LOX292, that had an estimated patient population of around 5,000 patients. This was because of the specific protein that they were targeting was expressed in 2% of lung cancers and 30% of thyroid cancers. So that low patient population would not have driven much value. So it's potential. There is potential that, you know, this FDA approved drug actually added some of that value. Now, when we compare that to the pipeline potential of an FTO inhibitor, those that have been on hot copper, I seem to do a lot of drum banging. I've been talking about this for a little while now, and this was, you know, a key area of interest for me. You know, trying to work out what is associated with FTO overexpression, and it appears that FTO overexpression is central to many different diseases. We have metabolic diseases, neurological diseases, and neuropathic pain, and so I don't know yet if an FTO inhibitor is going to be useful in these disease indications, but there is a lot of evidence to suggest that FTO overexpression plays a part in the pathogenesis or the progression or the, you know, maturation of these diseases. And so if we think back to our first in class or best in class, there are no current FDA approved FTO inhibitors for any of the diseases linked here. Okay, now combined, you've got about 4 billion patients worldwide, or potential patients worldwide. In 2019, the global drug market value for these different disease indications was $325 billion, and by 2026, it's estimated to be up over $500 billion. Now, what you then have is there's currently no FDA approved drugs for any of these indications for targeting FTO, and you then have the potential to be a first-in-class drug for any of these indications that might, you know, benefit from an FTO inhibitor. And because Byzantrine is so much more potent than all of the other competitors, you also have that potential to be best-in-class and first-in-class. And so obviously, you know, you wouldn't access that amount of funds, but a potent inhibitor that is first-in-class and best-in-class would access a certain percentage of that for whatever disease indication that might be. You know, and based on that information, I think it's pretty clear that the pipeline potential of an FTO inhibitor, and particularly Byzantrine, is far, far greater than the pipeline potential of the other drugs or non-FDA approved drugs that were bought out, or even Trudelbe. Limitations. I actually reckon I've done pretty good. The Perth guys were on to me about, you know, talking too long. So I'm at about 28 minutes now. I'm not doing too bad. My limitations. So I have inherent personal biases. You know, I'm invested in RAC, and I've tried my best to not let my biases influence, you know, my research or my interpretation of the diet. I'm putting my dietetics hat on. I've tried not to let my personal biases get in the way of objectively trying to look at this data and to try and determine a value. But I do recognize that my biases may be there, and they may be influencing the way in which I look at this data. I also recognize that, you know, this stuff is rough. It's really, really tough science. And, you know, I do have a bit of a background, but the oncology space, and particularly the FTO inhibition space, and all of the other drugs that I've looked at, it's very complex science, and I only have a limited amount of skills. So I recognize that. Now, for my personal biases and my research and knowledge skills, I've tried to cite as much as I can, and I'll put the original post, you know, in the description. I've tried to cite as much as I can to try and eliminate those personal biases and my research and knowledge skills, so that if anything, it is a tool, or it's something that investors can use for themselves to generate their own value or do their own research. And you know, if we all learn together, then, you know, we should be able to knuckle down on you know, good value or something of the sort. So I also recognize that trying to a limitation is knowing what was known prior to a transaction. So the evidence is always building, and it was challenging for me to try and lock into what did a pharmaceutical company know prior to a transaction about, you know, potential indications, synergies. So that may be a limitation. I may not have done that accurately. Another limitation is looking at the data through an FTO inhibitor perspective. Now, I have discussed this topic at length. I've been through all of the historic trials. I've been through the City of Hope paper numerous times, and I've tried to debunk my FTO inhibitor perspective, and I haven't been able to do that yet. And so currently there is no in-human data that shows that Byzantrine inhibits FTO. And so without that data, which we should maybe receive in the next 6 months, this remains a speculative point, and I'm going to announce it as a limitation. But I'll put the post in the description so anyone can read my research and make up your own mind. So, looking at specifically the non-FDA approved drugs, I believe that Byzantrine is far more clinically advanced. I believe that there are more synergies, or the evidence suggests that the Byzantrine is far more clinically advanced. The evidence suggests that there's more potential synergies and indications. It, like the other drugs, it has the potential to be first and best in class. And I believe that it has greater pipeline potential. Now, the average of those three buyouts, so the buyouts of Juno, Loxo and 47, comes to around 9.4 billion Australian, which at a 170 million shares in issue is about $55 per share. Now, because of how Byzantrine, because of the comparison of Byzantrine to these other non-FDA approved drugs, I think it is fair to say that 55 or 9.4 billion Australian is a baseline value. I don't see any evidence to suggest that it would be lower than that. And so I don't know what the upper limit is. I will not discuss the comparison between Byzantrine and Immunomedics, because it's at this stage it's difficult for me to judge value based on a comparison between an FDA approved drug and a non-FDA approved drug. I have my suspicions about what the value might be, but they will remain my suspicions for now until more data comes to light. And so, yeah, it's I hope that this video has helped some of you to try and understand, you know, why I'm excited about this space and why I think that this is the baseline value. I encourage anyone who is looking at this research or is reading any of my stuff to be critical and to jump on hot copper and let's get this discussion going, because, you know, I may have made some mistakes and I probably have made some mistakes, and there's definitely some areas that, you know, I could improve in, and hopefully we can start to really sort of knuckle down on a value of an FTO inhibitor. But so far so good. This is video number 2, guys. We've done well. You've had 33 minutes of me. The Perth guys are all wild. They probably just turned it off now, but thanks a lot for listening. I hope you got a lot out of it, and, you know, we'll see how we go for another one. Maybe, you know, the City of Hope number 2 paper will come out, and we might do a video about that if it's any good. And yeah, so thank you very much. I'll see you on the next one.